Welcome to Cybrary. I am Raymond Evans and I will be your subject matter expert for Cybrary's Web Application Penetration Testing course. In this video we will be discussing HTTP and HTTPS basics. So what will be covered? We're going to discuss what is HTTP, what is HTTPS, talk about TCP, and discuss which one is better, HTTP or HTTPS. So what is HTTP? Well, HTTP is the foundation of communication for all web applications and web pages. Whenever you're browsing any kind of website, you're generating HTTP traffic. And with that traffic, you're performing all kinds of different requests. And those requests perform different functions. So we have things like a GET request. It retrieves data. So every time you browse to a page, you're performing a GET request because you're getting the data and it's being presented to you in your web browser. A head request can be performed as well, and that's used to get metadata about the pages. Certain pieces of software will perform head retrievals to get metadata that it may want. There's also a delete request, which deletes resources off a server. So if you don't have a server locked down properly and you allow people to perform requests, somebody can actually delete resources off your server. Then we have post requests. Post requests when there's a submission of a web form or something like a forum. And then we have put requests. It's used to push resources to a web server. Sometimes this can be a bad thing because if you don't have a web server locked down properly, somebody can do a push request and push data onto the web server and actually push something like a piece of malware onto it. Now the malware won't execute. However, if you know that exact location that you put that item and you have your social engineering skills up, then you can actually trick somebody who works with those servers into possibly browsing to that on the server and executing it. You could say that you're somebody from whatever company is running that server, and you can say, hey, we got this new update that got pushed out to all the servers, except it needs manually executed. Can you please go to such and such folder and execute such and such file? And a lot of times that actually may work due to the fact that humans are the weakest link in any network. And HTTP uses port 80, which is important to know. HTTP, when you're browsing different web pages, different codes are generated. Now, you don't see them up front all the time. Sometimes they are only in the packets, but they're there. Things are happening in the background that you don't realize. If you use a packet analysis tool such as Wireshark, then you can actually look at those packets and view the different status codes. So some examples are the 100 status codes, which are informational, and an example of that is the 101 switching protocol. And then we have the 200, which are success codes. So if you successfully browse to a web page and you successfully get that data retrieved, you'll get a 200 code. 300 are redirection codes, and they give you different information about redirection. So if it's a 301, then that web page may have been moved to somewhere else, a different URL, and it's going to redirect you every single time. And then there's the classic 404, which is a client error code. And 404 is a file not found. So if there's a web page that you're looking for and that web page doesn't exist anymore, you're going to get a 404 not found error. And then 500 are server issues. So it's things like the 503 code, which is service unavailable, which means that that server is currently down. There's a lot more codes than just these. These are just some examples I decided to include so that way you had some kind of idea of the status codes. But you should definitely look into these codes further and understand them better. Because if you are using a packet analysis tool of something that happened, some kind of event that happened in an organization, then you will know what's going on based on these status codes. So, for example, if a redirection code happens and an individual is being redirected to a malicious web page, you can identify that redirection code in the packets. Then we have HTTPS. What is HTTPS? Well, HTTPS is used for secure communications. It uses port 443 and it uses SSL and TLS. It uses SSL certificates to ensure that the communication is secure. And those certificates are granted by a certificate authority. Now, it used to be that back in the day, SSL and TLS certificates used to cost a lot of money. Now, there are companies out there who still pay lots of money for certificates from the certificate authority. However, there is a bit of a small movement of getting free certificate in people's hands. One of those companies is called Let's Encrypt, and they are actually giving free certificates out to everybody. Now, it used to be that if you had HTTPS on your web page, people generally thought that your web page was a trusted and good web page because, hey, you're paying hundreds of dollars for your certificate. There's no way you're going to be a bad guy. I mean, those guys don't pay that kind of money for secure stuff for a user. Well, now this is coming back to bite people in the butt, these free certificates. So if you see HTTPS, yes, the page is secure, so you can trust the communications. However, you can't trust the page itself. You may go to a page that says, hey, give us your credit card information. It may be HTTPS, but that doesn't mean that that page is a page that you should trust. It just means that you're not going to be hit by a man-in-the-middle attack, or people aren't going to be listening to your communications. HTTPS uses certificates from a certificate authority, and how it works is, first, SSL certificates are exchanged, and those certificates are identifying, hey, I am who I say I am, and you can trust me. After that exchange happens, and both hosts trust each other, then the encryption keys are exchanged, and that's when all the communications are encrypted. So that's how HTTPS works in a nutshell. HTTP and HTTPS both work off of the TCP protocol. Now, there's two different kinds of protocols that you're going to see, TCP and UDP. TCP is a connection-oriented communication, whereas UDP is a connection-less-oriented communication. So what's that mean? Well, TCP does what's known as the three-way handshake. So whenever you go to browse to a page, you, host 1, send a TCP SYN packet to host 2. Host 2 receives that packet and acknowledges by sending a SYN-ACK packet back to host 1. So it's saying, hey, I see your communication attempt. I acknowledge that communication attempt. And then host 1 sends an ACK packet back to host 2 saying, hey, thanks for responding. And then a TCP connection has been established. Now, from that point on, that communication is used to ensure that all packets are received via the communication. And they do that with things like the sequence number, which is used throughout the communication to identify if a packet may have been dropped. However, if you're using something like UDP, that is a connection-less-oriented communication. And what that means is UDP just throws all the packets at whoever's trying to receive them, and it does not care if there's any kind of packet loss. TCP is great for browsing the web because you're going to get all your packets. UDP is great for streaming of media. If we use TCP for streaming of media, then the media would be slowed down substantially. One or two packets dropped here or there will not matter for streaming of media, but it will matter for TCP, because if you're dropping packets for TCP and you're trying to browse a web page, then you're going to not get content that you want from the web page. Whereas UDP, you may get a little bit of a downgrade in the quality of your streaming service. So which is better to use, HTTP or HTTPS? Well, HTTPS is always better to use. HTTPS prevents a man-in-the-middle attack, and HTTPS prevents eavesdropping from packet analysis tools on a network. So all that communication will be encrypted, and nobody can pick off your form field data or things like your credit card or sensitive information. So HTTPS is always better to use. If a site has an option to use HTTPS, always use that. If you have the ability to use SSL certificates on your web application, do it. It will only make your web application stronger. So what was covered? Well, I discussed what is HTTP. I also discussed what is HTTPS. I talked about what TCP is and the three-way handshake and how that works. And then I told you which one was better, which is HTTPS. Happy hacking, everyone.